The first one you are coming with the name. The second one you are coming with the operation, right? Operation. And the third one you are coming with the
Operand. And last one,
right?
comment.
And the last one is the
Comment.
I'm just making like this as a comment. Okay, you should understand. Okay, so we have 4 fields, right? And we learned about the what about the syntax? We are learning about the name we covered, right? The name, if you want to mention, it should be 1 to 31 character, right? Length maximum. Now you can combine either digit, you can combine the letter, right, for the name. You can combine the digits, am I right?
Yes,
and
sir.
the special characters, right? We know also what are the special characters, maybe underscore, maybe dot, maybe what should I say, the other symbols, right? So these are the special characters. By combining these, now if I use the dot, in that case you have to follow the rules. If I put like this ABC AB dot, is this the correct name?
No, sir.
No, sir.
This is not the correct name, right?
Yes,
But
sir.
if I write AB, this is
Correct.
dot, is
Correct.
this correct?
No, sir.
So this is wrong, this is correct, right?
Yes, sir.
So, and then for the number should be started. Can I start like 1 A B? Is this correct name?
No, sir.
No, sir.
It's wrong. If I write A B 1, that's going to be the correct one, right? So this is the things you have to understand for the name, right? For the operand, we know 2 things. The operations, that is opcode. What are the opcode? We can consider add, we can consider sub, right? We can consider like increment, decrement, this kind of things are the opcode. But what about the pseudo op? What about the pseudo op? Pseudo op, can you remember? Like you are declaring like proc, right? P-R-O-C, proc. What does it mean? That means you are creating a procedure. Pseudo op means you are giving the instruction, by writing this, the assembler getting a message, assembler getting a message that one procedures need to be created, like we are considering this is a procedures, one segment of a program need to be created, and there should be name, and then the name of this proc would be say like A, B or CD. Does it make sense? So how we can write? We can write A, B, P, R, O, C. Does it make sense? Last day you said you saw MAIN. That means main proc, right? Main is the name of the procedures. So that one you are considering as a pseudo opcode, and these are the opcode. So all these you are considering for what? For this operation. Does it make sense? Are you listening to me, guys?
Yes,
Yes, sir.
Okay.
Yes, sir.
So that is the, and who is this?
Sir, I'm Humaira. Sir, I have poor net connection. That's why I'm not connecting, sir. Sir, did you take attendance?
If you ask me, yes, I have taken the attendance. No worry about the attendance. You can be connected. I will check it. It is 2-hour session, right? At the end of the session, I will double check. Okay. Don't worry about the attendance. Okay. Now look at the operand. So for the operand, you see, we know that operand can be either registers and the words, right? So all the operands, like you can consider AX as an operand, you can consider BX as an operand, you can consider A as an operand, B as an operand. That means variables. Does it make sense? Variables, right? We are going to have a look even that one. We already finished the variable. Look at here, the operand field, the variable. And then we can have the 0 operand, 1 operand, and 2 operand as well, right? We learn about, if it is 2 operand, there is a issue about the source and destination. Can you remember? There is a issue about source and destination, right? So this source and destination, like if I write add, if I write here add AX, comma, BX, which one is the source and which one is the destination?
Yes, sir. AX is your source.
Destination and
BX is
the
So
source.
this is the source and this is
Destination.
So add, that means you are going to add the value of these two variables and the result is storing to the AX, right? To the destination, because this is destination. Does it make sense? So you are learning about the source and destination in terms of two variables. Okay. All right. So we will see all this now. This is about just a quick rescanning about the previous class. Okay. Also, we went to the today the an assembly instruction. Just wait for a few seconds. Okay. All right. So these are the numbers that we already covered also in the previous day. That how assembler recognize the binary number, decimal number, and hexadecimal number. Right. So for the hexadecimal number, make sure the number should be started with the digit and ending with the H character. So that's why look at this. This is the correct hexadecimal number. Why you are saying it is the correct hexadecimal number? Because this number is starting with the 0 and ending with the H. Does it make sense? But you are going to say this is the illegal one. Can you see the pointer, guys, that I'm using? Can you see the mouse pointer?
Yes, sir.
Okay, so look at this. There is no starting the digit, right? And that's why you are going to say this is illegal hexa number, right? Okay, all right. So please try to keep in your mind also, and this is how assembler recognize the number, right? So now have a look the program. The characters. How assembler deal with the characters, right? So if you are writing some characters, definitely just very easy to remember. You have to use the either double inverted comma or single inverted comma. Make sense? What did I say? Look at this. Characters must be enclosed inside the single or double quotes. Okay. For example, A, if you are writing the A, it should be either double inverted comma or just single inverted comma. Look at this, another characters string you are writing here, hello. So hello is coming inside a single inverted comma, like this one. This is single inverted comma and this is double inverted comma. Okay, and you are translated into there. When you are writing this kind of characters or string, you are converting it to the ASCII code by the assembler. So immediate after writing this kind of character, what should I say, character inside the double or single inverted comma, the ASCII will take the opportunity to convert it to the code. We know the ASCII standard details from the previous slide, right? ASCII, it is a 7-bit binary number, creating always 7-bit numbers, right? And you see what are the printable characters for the ASCII and what are the non-printable characters for the ASCII as well. Okay, and no differences between, like you can either directly write the ASCII code or the characters. Okay, so in the program, assembly program, no differences between using the A and 41. So this is hexa number. Make sure don't make a mistake with that. So 41H you are using. So when you are either you can write A inside the double inverted comma and 41H. So when you are writing a ASCII code, you don't need to bother about the single or double inverted comma. Simply you can write the code. So this is the ASCII code. You see, this is the excuse me. So this is the ASCII code 41. If you are writing 41H, the assembler automatically understand what you are going to mean by that. That means it is A, capital A. Make sure this is capital A. For the small a, there is another code maybe. If you check the sheet, you can understand. Is that clear? That what I mean by saying that there is no difference. So in the program, if you need to use a character variable like A, either you can write the full one or A inside the double or single inverted comma. So for it's very easy to understand. If we want to write some string in assembly code or the character in assembly code, we have to consider the either double or single inverted comma. In case if we are writing the characters, then that character is going to be converted by the assembler into the assembly code. But directly you can also use the assembly code as well for that particular character. It's up to you which one you will prefer. Okay, that is the things point you need to take a note or write down. Okay, and the variables, look at this variable. What is the understanding about the variable? Who can tell me? What do you understand by variable?
Variable is a container.
Container, sir.
Variable is a container. Yes.
Variable is a container.
Value is
Container
value.
Variable, you are saying that it is a container that will contain the value. Is that?
Yes, sir.
And the value of the variable always changeable. Is
Yes,
that?
sir.
Yes, sir.
Yes, basically you are right, but you can express it in different way. Variable is a kind of part of the memory as well. Whenever you are considering a variable, you know that that means you are allocating some portions from the variable, also from the memory. Okay, so say if you are writing int a, what does it mean? A is a variable and you are giving the what type of variable it is. It is integer type variable. So when you are putting the variable integer, I mean the type of the variable, the compiler will automatically know what is the memory size should be allocated for this integer A. Is that clear? This is the internal or logical aspect of declaring the variable. So look at here, is variable has a data type, is variable has a data type and is assigned a memory address by the program. Is variable has a data type. Okay, you are saying definitely. What are the data type in assembly language? That we are going to see very soon. Okay, so first of all, as I said, in programming in C and C++, you are assigning the data type for the variable. Am I right or wrong?
Yes, sir.
Yes. So similarly, if we are working with the variable in assembly programming language, definitely you have to consider the type of that variable. And you see, ultimately what you are doing, you are assigned a memory address by the program. So whenever you are doing it, you are going to assign some memory from the main memory. And look at this, data defining sudo of and their meaning as below. So data defining each and every variables. That means you are defining the data type, whether it is byte level variable or word level variable. Does it make sense? So look at these sudo op. These are considering not only proc, you are considering as a sudo op. You are also considering all of these as a sudo op. You see now sudo op, more example of sudo op, right? So here what you can see this is define byte. It's a kind of sudo op. Whenever assembler see this define byte, that means it can understand what you are going to do. You are going to allocate some memory, okay, from that portion. Look at this, data defining sudo ops and their meanings as below. So when you are going to define some variable, you have to consider this db or dw or dd or dq or data type. Define 10 bytes. So these are you are considering as a kind of data type for the assembly variable. Does it make sense? So first of all, you have to understand what is the meaning of this DB, you are defining the byte. DD, you are defining the double word. DW, you are defining the single word. So how many bytes in a word? I'm asking how many bytes in a word?
16.
16, sir.
2, sir.
16 bytes.
No, sorry, sir.
2 bytes.
Sir,
2
2, sir.
During the Viva, maybe you will get a one option. Whatever answer you were saying
2
first
bytes.
time, that would be considered. No second option. If you are saying 16 byte, oh no, sir. It doesn't make sense to me. Okay, so please be careful.
16 bits, sir.
Okay, so 16
Sir,
bits.
2 byte 1 word, or we can say 16 bit 1 word.
If I say how many bytes, why you are going to say bits? I will cut the mark also for that. That means you are not sincere about my questions. If I say how many bytes, why you are going to say bits? Maybe you can take a minute, you can take a seconds, but you try to say the right answer, okay? Is that clear? And why I'm going to be strict with that? Because this is so easy. Is that clear? So please practice. Anyway, just I think it would be okay, no worry about that. So we have the other pseudo opcodes like DQ. What does it mean? Define words. Okay, all right. And DT, define 10 bytes. You see, all of these are, you are considering what? You are considering as a data types. Okay, so as you are considering like integer and then blah blah blah. So here you are considering like DB, DW. We will see the example very soon. But for our case, you know, whatever assembly programming we are practicing, we need only two. The first two. We will practice with the DB and DW. That's it. Unless you are working for a very large project or complex logics, or you are going to develop some very sophisticated system using the assembly code. In that case, you can go for the rest of the like DQ or DT, right? That means you need a more big space. Okay, all right. So that's why we are going to have a look. We do practice only with this. If I ask you, what does it mean, DW? Or I can ask you, what do you mean by DW? I can ask you, what do you mean by DB? Please make sure. Okay. All right. Now we are going to be with the example. Look at here, byte variable. Byte type variable. Say you are declaring, this is syntax. This is a way how you can define a byte type. You know the syntax, right? The grammar, the rules. So this is a syntax for the byte variable. So this byte variable, you are considering, you are giving the name of the variable, and then you are mentioning whether it is byte variable or word variable. So it is clear that it is a byte variable. Why? Because you are writing define byte. Is that clear to everyone? So let's see the example. Alpha DB, and what is that? This is a initializer. The value of this variable alpha and the type of the variable is DB. Is that clear? So alpha is the name of the variable, and that this alpha is a byte type variable, and the value of the alpha initializing the variable byte with the value. It is empty variable. Is that clear to everyone?
Yes.
Yes, sir.
Okay. So now similar for the word variable, you are defining the variable. The name of the variable is the WRD word. Okay. And the type of the variable, it is what type variable, because you are mentioning DW if you are defining the word, and you are initializing by 2 or -2. I think this is a different, not negative, maybe some kind of PDFs problems. Okay. So this is a kind of the things you are defining the variable, and also you are telling whether it is byte type variable or what type variable. Is that clear to everyone? Yes. Yes. Why you are stopped
Sir,
by
for
saying sir?
what table, sir, for -2, how it?
It is,
don't
as I said,
understand.
it can be -2 even the value. It can be -2, it can be +2, it can be -4, it can be +4. Okay, so this is a number, and what do you think? Is and every number will be converted into the binary number, right? So that many bits will be converted to the, it's going for be allocated for the memory. So it is what, 16 bit, right? 16 bit. That means what is the binary value for 2? It is 10, right? And rest of the 14 bit will be 0000 before the 10. Does it make sense? So that's the initialization. That means if you don't want to initialize, then you have to use the question mark. If you want to initialize, then you have to define the number here, right? Okay, now you know the array variable. Do you know the array variable?
Yes,
Yes,
sir.
sir.
What is the concept of array? Can you tell me first, that you learned from the C and C++?
Sequence of characters, sir.
Sorry?
Sequence of characters, sir.
Series of
Array?
same type characters, sir.
Collection of characters, sir.
Sir, sequence.
Yeah, collection of same type characters.
So you can say array is a kind of variable that
Sir.
contain the similar types
Type
of
of data.
values, right?
Yes, sir.
Say if I say integer a, it is also a variable. I can also write integer array type variable, right? A, and then I am giving the range like 10, 100, right? That kind
Yes,
of
sir.
range I can give. Okay, the similar concept we are going to apply. So you know do you know the how the array is addressing? Say if I like array type variable integer a,
Yes, sir.
inside the bracket I am mentioning 10. What would be the maximum address?
10, sir. 0
Wrong.
to 9.
0 to
0 to
9.
9.
It is
0 to 9.
So maximum up to the 9. I mean
0
altogether
to 9.
it is 10. Right.
10.
So similarly, you see,
9.
but can you take a break when you are taking the address? Like you are writing A0, then you are taking A8, A9. Are you writing like this, or you have to maintain the sequence?
Maintain the sequence, sir.
Maintain.
the sequence.
Okay, if you understand that, then it will be help us to understand this one as well. Okay, array type. You see, that's why they are saying a sequence of memory bytes or what? Array. We can also declare array type variable in assembly. And what does it mean? Array. That means you are going to say it is nothing but a sequence of memory you are going to use by declaring the array type variable. Let's have a look. This is a array type variable, byte array type variable. And what is that? You see? And what does it mean? Why they are giving the 3 values here? What does it mean?
Array, sir.
Is this the array? Or the value of the this is the, not the size, this is the value, the initializer, because you know the array, we can understand 3, right? It is the maximum 0 to 2 will be there, right? So a, say binary array, this is the name of the array, this is the type, byte level array, and these are the value for that. So you need 3 address for storing these 3 value. Am I right or wrong?
Yes, sir.
So B array 0, B array 0 plus 1, B array 0 plus 2.
True, yes, sir.
Is that clear? What you are doing? This is the internal. Usually as a programmer we don't see, but as a student of CSC we understand what is the internal scenario when you are writing a kind of things, right? When you are declaring a integer type array and its size is 3. Does it make sense? So where we can see the sequence? With the address. Where is the address? It's 200, 201, 202. So for the first value, it's starting at the memory 200. For the second one, it is 201. For the third one, it is 202. What would be the fourth? If I give another value here, 40 haze?
203.
203, sir.
Tell me the complete picture of this.
But
Sir, B binary array plus 3.
plus 3, 2,
And here?
0, 3 a's,
And here?
48.
The value.
408. So this is the internal picture of the array. Similarly, we can go for the, you see, we can go for the word array as well. What is that one? Word array. Look at here. Word array you are defining with the similar way, but you have to have a look. Where is the difference? Tell me. What is the difference in compared to the byte level? Are you going through that, guys? Your time is 1 minute.
That it's increasing by 2 values. So increment is 2, I think.
It's increment by 2. Okay, my next question is why?
This is a word, sir.
We have 2 bytes as its word.
Great.
Each
Perfect.
time increment.
Absolutely right. That means every time it's increasing by 1 word. And we know that it is working as a byte level, right?
Yes.
So 2 byte equal 1 word. So assembler simply can understand that it is a word level, increasing by word level. That's why you see how many, you look at here, the address is also increasing by 16 bit together, right? 300, 302, 416, I mean 6. And if I give another value, say 400, then what would be the structure here?
0308.
0308, and here will be 400 and it will be 8. Is that clear? So this is the concept to work with the array variable and the normal variable. Is that clear to everyone, guys?
Yes, sir. For address in previous slide and also this slide, sir, how can we say that the address is fastest address is 200H, or for this slide?
It's automatically assigned by the assembler. When you are declaring the array in C or C++, do you know in which memory allocation, which memory space you are going to allocate?
No, sir.
Okay, it is the internal logic.
Very
you have to
internal.
understand.
Okay.
It is the logical structure or logical aspect of the microprocessor. Okay, so it's there is a algorithm. If you are taking the like computer organization architecture, I believe you should understand the logical aspect, how the microprocessor will work with allocating the assigning the memory, okay, for this kind of purpose. Okay, that is
So for assembly language, we won't.
about the logical aspect of the computer system. Okay, all right. So now we are going to have a look the instructions. What are the basic instructions we need to use when we are writing the assembly programming? Okay, what are the basic assembly instructions? So these instructions sometimes we can use as a, we can see the combination of the like name, the pseudocode, opcode, pseudo opcode. Sometimes we use instruction means we are going to consider the opcode. We will focus on the opcode and the operand. Okay, opcode and operand. We see we have more than 100 instruction in assembly. I mean this 8086 processor can cope with the more than 100 instruction. But in our case, we are just going to practice very few, maybe 6 or 5. Okay, sort of instruction. Not only these 100 instructions, right? So as you mentioned that, what kind of, basically we are going to do practice with these 6 instructions. Okay, because most of the time we will practice for the data movement, like move, shift, exchange, that sort of things we will use. Okay, and also the arithmetic operations. Guys, are you listening to me? Everyone?
Yes,
My voice is clear?
Yes, sir.
Yes.
What about the others, like Rabab, are you listening to me?
Yes, sir. I'm here listening.
Okay, you are listening my voice, right? Humayra Afrin.
Yes, sir. I'm listening.
Okay, Sadia Tabassum.
Sir, I'm listening.
Okay, all right. And Shampu Akhtar.
Yes, sir, I'm hearing.
Okay, thank you so much. It seems like still you are sleeping, Shampaktar.
No, sir.
Okay, all right, thank you. Okay, guys, please, if you are not listening, sometimes you face, as I said, we need for the data transfer and arithmetic operations 6. Okay, so we will do practice with these 6. So first of all, we will consider first 2 instruction, that is move and exchange. We know move means what? Move means just you are transferring, and exchange means you are swapping. You are taking from container A to B, and the content of the container B is coming to container A. That is the exchange. Does it make sense? We will come to that point very soon.
Sir, one doubt, sir. Sir, here move or exchange, or if I say move and exchange, so it is counting as 2 instruction set.
2 instruction set. Move is different, exchange is different. We will
And
see
sir,
that.
the first line 100 instruction sets, that means as it mentions sets, then is it referring like previous we have learned that 5 computer follows 5 instruction sets to execute any program. So is it same thing here? As
Instruction sets. No. That's the how instruction is executing. That's the 5 instruction set. That means face and execute.
yes, sir.
Okay, this is assembly code. That means what are the code you are using, and the code you are writing the code here, like you are writing move AX BX.
Yes, sir.
Okay, to understand this instruction, that instructions we are using 2 purpose, for data exchanging and movement, and also for doing some arithmetic operation. Okay, so in that case we are going to use the 6. Now let's start with the move. What is the purpose for the move? So used to transfer data between registers. So move, you are saying that, guys, don't forget I said you have to give me reminder at least 20 minutes earlier. What time we will finish the class?
12.
Sir, 12.
At 12. That means 10,
40.
11, 11, 20,
Sir,
11:30.
11:40.
11:40,
Oh,
yes,
okay, sir.
11:40, you will just give me the reminder, okay? Those who you are coming. I will also try to keep in your mind, no worry.
We can
Okay, sir.
Okay, all right. So only 6 we are going to practice, and the move is the first one. What is the purpose of the move? They are saying the purpose of the move and exchange, you are just using for transferring data between, look at this, from where to where we can transfer the data. This is important to understand. Let me repeat, this is important to understand, that from where to where we can transfer the data. Look at this, you can transfer the data between registers. What can I say? AX BX, AX CX, CX DX, DX AX. These are the registers. We know the registers, right?
Yes, sir. That
So we can move the data between the register, that is one part. Between a registers and memory location. We can also allow to transfer the data between registers and memory location. So memory location means what? We can consider either byte or the word, right? So maybe word 1, maybe word 2. So you can like do that with the variables like AX, word 1, AX, A, BX, B, C. These are the variables, right? When you are taking the variable, that means you are getting the space, memory location. Am I right? So that is another. So we can move the data between the registers, between the memory and the registers. Memory means what? As I said, it's a kind of variables. So I can write AX, A. That means value of the A is going to be stored into the AX. I mean going to transfer to the AX. Is that clear? So another one, to move a number directly to the registers or the memory location. What is the scenario for that? A number directly you can move. Say I can write A, 5. That means 5 is going to store into the A. This is for the memory. I can also write registers AX, 5. 5 can also going to be into the register. So 3 different combination we can consider for moving the data. In between the registers, and memory, in between the directly numbers and either registers or memory. Is that clear?
Yes,
Still examples are waiting for us. But before, I'm just going to block your memory with this concept. Please try to, so where we can transfer the value using this instruction between the registers and memory location, and also you can move a number digit. The real example of that. What does it mean actually? I'll give you another 2 minutes. Have a look on that and tell me whether you understood the things or not. Slide.
Yes, sir.
Yes, sir.
Okay,
Yes,
please try
sir.
to understand.
Yes, sir.
Yes, sir.
You understood? Who said yes,
Yes,
sir?
sir. Yes, sir.
Sir,
No, sir, it's not fully clear, sir.
2 minutes not done. Still you have 2 minutes. I mean, still you have 1 minute more to give you a try. Hoymonti Rani, are you connected? Are you looking the screen, Hoymonti? Okay, all right. Okay, guys, tell me, raise up your virtual hand that how many. Sorry. Yes, I can see it's increasing. Ajat Hassan Jim, you understood. Two student, you raise up the virtual hand. If you understand, please raise up your hand. Only 8 students, 10, 11, 12. I have 44 students connected. Okay, 13 participants, you raise a hand that you understood. Okay, good. Still it's increasing or not? Even someone you put down your hand. You are putting down your hand. Okay, that's fine. Thank you. That means half of the students, even less than half of the students, you understood. That how it's working. Okay, look at these. Guys, here you can simply have a look that what's going on. Move means what? Are you listening to me, guys?
yes, sir.
Yes, sir.
Okay, move means you are just transferring data. We know that we can transfer data between the registers, between the memory locations, okay, and registers between the, numbers directly moving to the either registers and memory location. Now look at this. We are moving data in between what? Can you tell me? Is
Register
this
and memory.
absolutely right? We are transferring data in between the registers and memory. So look at this. Which one is the source, memory or registers?
So word memory.
The
Memory is the source and register is the
Destination.
destination.
Great. So you understood, right? So now look at this. What is the scenario before executing this instruction? So you have the value for the AX. It is in hexa, don't make a mistake. 006, this is the value for AX. Before executing this instruction, and you have the value for the memory, it is 008. Does it make sense? So now after executing the instruction, what's happening? The value of the memory word is going to store into the AX. So look at this after, it is written here, after. What is the value for AX after executing this one?
0, 0,
That means
0.
the value of the words going to be stored into the AX, that is 008, and the value for AX, ultimate value for, the word is going to be the same like 008. Is that clear?
Yes, sir.
The here move operation means we will permanently move the data or copying the data.
You are just transferring the data. You are just copying. That's why it is here.
Copying, or that's why both place we will have the same.
Yes, that is the scenario is telling you.
But generally,
Right.
sir, in computer we know moving it means permanently, and copying is.
No, moving you can either do the copy and cut.
Oh, yeah. Okay, sir.
Both are
Sir,
the.
can you repeat?
Okay, sir.
Can I? Should I repeat? Yes. Someone, students, can you take the opportunity to explain this one?
Yes, sir.
Yes. Taufik, you can take.
For this instruction, we have move AX word 1. So here our source is word 1, and the destination is AX. That means register. So before execution, we have the value of register AX 006, and the value of word or memory is 008. So after execution, we can see the value of word is moving or transferring to the register. So it becomes 008, and the value of word or memory remains same as we are copying.
Is that clear?
Okay, sir. Clear.
Sir,
Will it
one
copy paste?
question, sir. What about the value of register 0006? What happened?
Yeah, it will be replaced. Whatever value is updating, because definitely register has a value, right?
Yes,
Now
sir.
the new value for the register is going to be 008. It's going to be replaced,
Okay, sir.
right? So again, if you are using these registers, say
Rotate
again
the-
you are writing move AX 5. Then
Yes.
what is the value for the AX that time? The 5. So this 008 will be erased.
Yes, sir.
Does it make sense? I mean, it will be updated. Is that clear, guys?
Yes, sir.
Yes.
So if I give you another example, can you just draw a picture in your book? So write the instruction first. Write the instruction first. I'm giving you example like move AX and AC. I am saying that move AX, comma AC. Okay, value for AX 0005 and value for AC is 0110. Now draw the picture and show me exactly as like after and before.
Can you see the value of AX again?
Value of AX, I said maybe it is 00. What did I say value?
0005.
0005, yes, AX. AX it is 0005 and 0110 I said for AC.
Sir, can you say the question
Done?
again?
I told you to execute the move instruction as you saw on the screen, right? The same scenario you are doing, writing an instruction. I said move AX, comma AC, and I have given you the value. You have to draw the picture.
What is the value for AC? I didn't hear it because of the network connection.
Okay, AC, value for AC is 0110.
Yes, sir. It's complete.
Done it?
Yes, sir.
Between the two resistors. Does it make sense?
Yes, sir.
The second one is you are moving in between the resistors. So can I give you value for AX, say 008, 0008, and for BX 0006. Can you draw the picture? AX 0008 and BX 0006. What is the move? Can you draw the picture?
AX 0008 and BX 0006.
Yes.
Sir, when we say between registers, can it be any register among, like we have
Yes,
three
usually general registers. Okay.
usually general register.
Yeah. Is that done, guys?
Yes, sir.
Can you show me your paper? Jim, Mr. Jim. Sorry, Ajim. Mr. Ajim, are you connected?
Yes,
Where
sir.
you are? Where is Mr. Azim? Washim? Sabir?
Yes, sir.
Azim, show your paper. Did you do that?
No, sir.
Why? Okay, all right. Thank you, guys. So let's go for the next instruction. We are going to see that how does exchange work. So if you understand the
Hello, sir.
Yes, who is speaking?
Sadia, can you
Yes.
repeat that topic? I missed it.
You were disconnected.
Yes, sir.
From where you disconnected?
This slide.
Hmm? This slide, yes. Just showing, guys. Can you? We are just learning that how data is passing, how data is moving from one or register to another register, or from one register to the memory. Okay, that's what we are looking here. Okay, so I believe if you look at the red color lines, you can understand. Before executing this instruction, the scenario like this, you see the value for AX like 006, and value for the word, it is the word we are considering as a memory because it is a variable just. Okay, and this is the 008. So after executing, you see this is the after, the value is changing. This, the value of the source is going to be inside the destination, because we know the AX is the destination, the register. So now the new value for the AX is the 008. So that's what we are learning. Now we are going to have a look. You see, this is the legal combination of operands. Now let's have a look. That legal combination of the operands we are considering, that you see for this legal combination for the move operation. Make sure, let me repeat, I'm saying this is the legal combination for the move operation. So you can see the two parameters here. One is the destination, another one is the source. So you can see the combination. So we know which one is the destination, which one is the source, right? Destination is the first one and the source is the second one, right? And before source and destination, we can see the operation like move, right? Now let's see what are the legal combination. So look at this. If I consider source general registers and for the destination also the general registers, that means we are right. We can transfer, we can apply the move. That's why it is yes. But what about this? Destination is a legal, I mean the segment. You see, look at here, destination, segment registers. And also source is a general registers. Is this yes or no? It is also legal. So registers, whatever registers it is, it doesn't matter. Destination is a segment registers and source is a general register, it is yes. Destination is a memory location and source is a general register, it is yes. But look at here. Guys, are you listening to me?
Yes.
Okay.
Yes, sir.
Now the last one, the destination is a constant and source is a registers. What is the scenario? Can you remember? Destination is a constant. So if I write move 5, CX, is this true?
No, sir, it is not possible.
No, sir.
It is not possible. That's why it is no. Is that clear? If the first one is clear, then second one should be also the clear. I mean the combination, how the combination is coming. Is that clear to everyone?
Yes.
So let's go for the second one. It will be more clear. So we have the destination registers, general registers, and the source like segment register, it is legal, yes. But for the no, segment register destination, like we can consider code segment, data segment, right, comma, segment registers. So source segment register, destination segment register, it is illegal for the move. Is that clear? So similarly others, what about this one? Can you tell me guys why it is no? Why it is no?
Sir, because source operand constant and also destination operand is constant. That is why it is wrong.
Perfect. So can you give me an example for this, Shahnas?
Sir, here not specify the register location. That's why the problem.
No, I'm asking the example of this scenario. Example, move, what you are writing then?
Move 7, comma
No,
7.
like
Move,
move 5,
move
5.
7, comma 7, move 5, comma 5. Constant, constant. So this is wrong.
It can be any constant, sir. Yes,
It can be any constant. Move constant, comma constant.
yes, sir.
Does it make sense? So that's why it is wrong. So this is the legal combination, or you can say this is a quick chart of the legal combination for the move operation. Similarly, we are going to see the similar sort of chart for the exchange operation. Before looking into the exchange, that chart, we will see the others one as well. Okay, so let's have a look here. A few basic instructions. Still we are going to see the exchange. As I said, exchange means what? Is you are going to swap. The A will be to the B and B will come to the A. Does it make sense? Yes. The general meaning of the exchange. It is not like a move. You are transferring, move also you are transferring, but you are doing the copy, right? But exchange you are swapping in between the two registers or registers variable, I mean the memory. Look at this, exchange operation is used to exchange the contents of two registers or a registers and a memory location. Contents of two registers or a registers and a memory location, or a registers and a memory locations. Now let's have a look the syntax first. So this is the grammar. If you want to write the exchange operation, then you have to maintain the source and destination. You need the two variables. One will work as a source, another one work as a variable. Are you listening to me, guys?
Yes, sir.
Yes,
Yes,
sir.
sir.
Right.
Yes,
Now
sir.
you can see the exchange. You see what is AH and BL? Is this registers or memory or constant?
Sir, register.
Memory? Have you seen
Yes,
this?
sir. Higher byte of
Sir, it is register, sir.
sir.
Someone
There
you
will be
already
a
come
high
up with
byte
the
or
right
low
answer.
Sir, higher byte of
Sir, here
accumulator
high byte or
register
low byte,
and
kilometer
lower byte
register
of
and base register.
base register.
Okay, then what we can understand by looking this instruction, that means we are exchanging the value in between the lower byte of the base registers and higher byte of the accumulator register. So value of the BL will go to the AH and value of the AH will come to the BL. Does it make sense? So we need the two registers, then we can show the AH for the accumulator, we can show the AL for the accumulator. Then another register we will also show the BH and BL. Now we are showing the exchange in between this. Let's see. Can you see the general picture of the two registers?
Yes, sir.
Before you have the upper part, upper byte of the AH, I mean the AX, and lower part of the AX. And similarly you have, and also with the value, look at what is the value for AH?
1A.
1A. And what is the value for AL? 0, 0.
0,
What is the value for BH?
0, 0.
0,
And what is the value for BL?
0, 9.
So now 05. Yes. So now we are trying to exchange. That means BL should go to the AH and the value of A1A should come to the BL. Does it make sense?
Yes, sir.
Yes, sir.
Okay, all right. So that is the point you have to understand. Exactly, we are going to see this one. Is that clear?
Yes, sir.
Is that clear to everyone?
Yes, sir.
How many students you understand this? Raise up your virtual hand. Again, I want to see. So faster, yes. 16 students, 17, 18. How many students you are connected? 45, 44. Yes, 22 students you understand. How about the other students? 22 students you are understanding this one. How about the other students? $22. Okay, all right. That means some students you have a problem, right? Okay, guys. So now let's try to understand the picture that we are exchanging the value in between the two resistors, right? So next we are going to do practice with another one. We'll do the practice and then we are going to stop the slide and we'll just go for the another activities. As I told you to give me the reminder, I'll stop sharing this one and what should I say? Exchange CHG. This is the exchange. I'm going to make it like BL, CH. Does it make sense? So BL, I need the value for BL. I'm going to give the value 11 and CH, the value is 1D. Is that clear, guys? So what about the things? We are going to change the value. The value for CS will go to the BL and the value, and the value for the BL will come to the CH. Is that clear?
Yes, sir.
That's the exchange. Now you are going to have the two resistors. So we have the two resistors. One is the here. This is, can I say this is the BX? This is BX and BX has a BL, the upper part, and the BX has a, it should be BH and this should be BL, right? So now let's have a look. The BL has a 11. The value is 11. And what is the BH?
What is the value for CH, sir?
Say AB. I'm going to give the value for BH AB. Is that clear?
Yes, sir.
Already finished with the BX. Now CH. So can I put here like the value, this is CH and I will put the name, this is CL. Is that clear? What is the value for CH? 1
D.
And the value, say for example, it is 00. Okay, this is before executing this, what should I say, this instruction, we didn't execute. So this is the picture, right? Now after executing the picture, what we can see, we need to draw the two. This is after, right? This is, we are saying this is the after. After execution. So we know that we have two parts for the BX and CX. So this is our BX. I'm sorry, B H, and this is BL. And this is our CH, and this is our CL. What is our job actually? The value for CH should go to the BL. What is the value CH? 1D, right?
Yes, sir.
1D should go where? BL. BL. So this should be 1D.
D.
What is the value for BL?
1 1.
1 1. 1 1 should go where?
CH.
CH. Where is the CH? This is the CH, right? And it should be 1 1. Is that clear?
Yes.
So now B has, you know, it is AB, and we have the CL, it is 0 0 0. Does it make sense that how it is working? Is that clear to everyone? So please guys, if I ask you some questions in exam, please try to show the picture.
Sir.
Sir, I have a question.
Sir.
Yes, Mehdi Hassan Abir first.
Sir, here you didn't give the value BH and CL. So here may we put any value?
Yes, you can put any value. You can put any value. But make sure that I have given BL and CS. I have given the value. Can you see this part?
Yes, sir.
Yes,
I have given the value for the BL and CS. The other two part I didn't give. Because
Sir, I have a question, sir.
Yes, please.
Sir, can I write first, sir, BL, then BH, sir? Here you write, sir, BH, then BL, sir.
Which one? This one? First you want to write the BL and BH? No, you cannot. Because that means you have the problem with the understanding. Because the where should be the lower byte. That means the upper byte you are becoming the lower byte, and lower byte you are considering the upper byte. Does it make sense?
Sir.
So
Yes,
this
sir.
is another understanding. Please make sure. Always the upper byte we are considering the leftmost bytes, and the lower byte we are considering the rightmost byte. Don't make a mistake with that. This is another good question. Thank you. Yeah. Okay, is that clear to everyone? Guys, is that clear to everyone, or still it is not clear?
Yes, sir.
Okay, now we'll go for the, I'm stopping again. So, yes, I will finish with this slide, no worry. So a few basic instructions here, exchange, how the exchange will work. So we know the combination for the exchange, right? So legal combination of the operands for the exchange. Legal combination. Tony Sharkar, if you want to eat something, the camera should be off. Don't forget you are in a class. Okay. All right. So the legal combination of the operands for the exchange. What is the operation for the exchange? Legal combination. We saw from the move operation, now the exchange operation. Okay. Now look at these, source and destination. Source and destination. For the source, you see, for the destination you have the, let's consider destination first, because we are writing destination first when we are writing the operation. Okay. So general registers and memory location, two options. We don't have the constant. Don't forget, when we are doing the exchange, we don't have the constant. Okay. Now look at this general registers and the source. Here, what we are considering. General registers, AX, BX, CX, DX, okay, that's fine. And for the destination, we can also consider, that's fine. These are the legal. Registers to the registers, okay, you can look forward. Registers and memory, okay, you can look forward. Memory, you see, general registers and memory locations, yes, that's fine. General registers, destination, you are considered the general registers. And for the source, memory location, that's fine. But look at this. For the exchange, memory location and memory location. For the exchange, if I write A comma A, is this correct? If I write A B comma A B, is that correct? Registers, I mean the memory location, it is illegal. Does it make sense?
Yes, sir. Sir, this is ambiguity problem, sir.
And you should understand that there is already no issue about the constant. But memory location, the same memory location, how you can consider for the source and destination? You cannot, right? So that is the concept. I mean the same location, you are not going to use for the two different variables. Do you think it's possible? Is this understandable by everyone? Guys, are you listening to me?
Yes, sir.
Okay, so what is the restriction? What is the restriction for the exchange? That means no constant and memory location to memory location. So both these are the illegal. So we cannot write any source and destination as like a memory location and the memory location. Okay.
Sir,
Yes, Bazit.
what if it is different memory location?
How do you make sure the different memory location?
In memory there is
Memory location